How to fix system freezing when launching Rust by adjusting virtual memory. Welcome back to Teknobalta. Today, we're addressing a prevalent and frustrating issue for many gamers. Persistent system freezing when launching demanding titles like Rust. Even on seemingly capable hardware, such as an Intel i3-10100F, with a GTX 1650 and sufficient physical RAM. This deep dive guide will explore why this occurs, often pointing to an overlooked but critical system component, virtual memory, also known as the paging file, and provide a comprehensive, step-by-step methodology to diagnose and resolve these debilitating freezes. We'll delve into precise adjustments, driver integrity, system diagnostics, and optimization techniques crucial for maintaining system stability under high load. Visual aesthetic description. Left side crash. A dark, crimson-toned screen showing a gamer with a look of intense frustration, hands thrown up in despair. In the foreground, a modern Windows system error dialog box dominates the view, its interface a stark red warning. The dialog reads, "Windows critical error. Your system has encountered a severe resource allocation failure, leading to a complete system lockup during application launch. Error code 0x00000007, a KERNELDATAINPAGEERROR. This may indicate issues with memory management or storage subsystem integrity. Please restart your computer to recover." The entire scene is rendered in hyperrealistic 4K, professional lighting, emphasizing the distress. Right side fixed. A vibrant, emerald green-toned screen featuring the same gamer, now with a triumphant and satisfied smile. Rust is depicted running flawlessly on their monitor, showcasing smooth, high-fidelity gameplay. The character gestures heroically towards the perfect game performance, bathed in bright, professional lighting that highlights their relief and success. The imagery is 4K, hyperrealistic, conveying a sense of profound accomplishment. Understanding virtual memory and its critical role. Virtual memory extends your system's physical RAM by using a portion of your hard drive, primarily to offload less frequently accessed data and prevent memory exhaustion. Even with 32 GB of RAM, an improperly configured paging file can lead to resource contention, causing hard system freezes when high-demand applications like Rust attempt to allocate large memory blocks. Properly adjusting this setting is paramount for system stability and performance. Navigating to virtual memory settings. To begin, open the Start menu and type System, or This PC, then right-click on this PC and select Properties. From the System Information window, navigate to the Advanced System Settings option, usually found on the left pane, to access performance-related configurations. This will open the System Properties dialog, where critical system parameters are managed. Accessing performance options. Within the System Properties dialog, locate the Advanced tab and under the Performance section, click on Settings. This action will open the Performance Options window, which allows for granular control over visual effects, processor scheduling, memory usage, and virtual memory. Careful adjustment here directly impacts system responsiveness and resource allocation. Modifying virtual memory, paging file. In the Performance Options window, select the Advanced tab again. Under the Virtual Memory section, click the Change button to open the Virtual Memory Configuration dialog. This is the crucial interface where Windows manages the size and location of your system's paging file, a critical component for memory management. Disabling automatic paging file management. Before setting custom values, ensure you uncheck the Automatically Manage Paging File Size for all drives option at the top of the Virtual Memory dialog. This grants you manual control, allowing for precise configuration tailored to Rust's demanding memory requirements and your system's specifications. Without this, Windows might dynamically resize the file inefficiently, causing performance dips. Selecting the optimal drive for paging file. Identify your primary system drive, typically your SSD-C drive, and select it for the paging file allocation. Utilizing an SSD for virtual memory significantly improves read/write speeds compared to an HDD, reducing latency and preventing bottlenecks that could contribute to system freezes under heavy memory pressure. This ensures the fastest possible access to offloaded data. Calculating and setting initial paging file size. For your 32 GB of RAM, a good starting point for the initial paging file size is 1.5 times your physical RAM. Convert 32 GB to MB. 32 1024 equals 32768 MB. Then calculate 1.532768 MB equals 49152 MB. Enter this value into the initial size, MB, field to establish a substantial and immediately available virtual memory pool. Calculating and setting maximum paging file size. The maximum paging file size should ideally be between 2 to 3 times your physical RAM, or a value proven effective by other users, such as 24156 MB from the user data, especially if you have 32 GB RAM. For a more robust configuration, consider 232768 MB equals 65536 MB, or even higher, to prevent scenarios where memory exhaustion could trigger a system freeze when rust demands peak resources. Input this into the maximum size, MB, field. Applying virtual memory changes and restarting. After entering both the initial and maximum sizes, click Set, then OK on all open dialog boxes. Windows will prompt you to restart your computer for the changes to take effect. A system restart is crucial for the new virtual memory configuration to be fully implemented and recognized by the operating system and applications. Performing a clean graphics driver installation. The outdated or corrupted graphics drivers are a frequent culprit for system instability. Download Display Driver Uninstaller from Wagnardsoft.com and the latest NVIDIA driver for your GTX 1650 from NVIDIA official site. Boot into safe mode. Run to thoroughly clean all previous driver remnants. Then restart your system and install the fresh NVIDIA driver. Updating chipset and essential system drivers. Beyond the graphics card, ensure your motherboard's chipset drivers, audio drivers, and network drivers are up to date. Visit your motherboard manufacturer's website or the respective component manufacturers to download the latest versions. These drivers facilitate proper communication between system components and can prevent unexpected freezes caused by driver conflicts or inefficiencies. Verifying Rust game files via Steam. Corrupted or missing game files can lead to crashes and freezes. Open your Steam library, right-click on Rust, select Properties, navigate to the Local Files tab, and click Verify Integrity of Game Files. Steam will automatically check for and repair any inconsistencies, ensuring your Rust installation is complete and error-free. Adjusting Rust in-game graphics settings. Rust is notoriously resource-intensive. Launch the game and access its graphics settings. Start by lowering demanding settings such as overall quality preset, anti-aliasing, shadow quality, and draw distance. Gradually increase them until you find a balance between visual fidelity and stable performance, minimizing the strain on your GPU and system memory. Monitoring system resources during launch. Utilize Windows Task Manager, Control+Shift+ESC, or Resource Monitor before and during Rust's launch. Pay close attention to CPU, RAM, disk, and GPU usage. Identifying which resource peaks or bottlenecks just before the freeze can provide critical clues about the underlying cause, helping you pinpoint specific areas for optimization. Checking system event logs for critical errors. After a system freeze and subsequent restart, examine the Windows Event Viewer. Navigate to Windows Logs System and look for critical errors red exclamation marks, or warnings, yellow triangles, around the timestamp of the freeze. Specific error codes or messages can indicate hardware failures, driver issues, or other system instabilities. Scanning for malware and rootkits. Malicious software can consume significant system resources, leading to performance degradation and unexpected freezes. Perform a full system scan with reputable anti-malware software like Malwarebytes or Windows Defender. A clean system ensures that background processes are not illicitly consuming memory or CPU cycles. Disabling unnecessary background applications. Many applications launch with Windows and run silently in the background, consuming valuable RAM and CPU resources that Rust could otherwise utilize. Open Task Managers, Startup tab, and disable non-essential programs. Additionally, close any background applications before launching Rust to free up maximum resources. Running System File Checker, SFC, and DISM. Corrupted Windows system files can lead to instability. Open Command Prompt as an administrator and run sfc/scano to repair protected system files. If issues persist, follow up with dism/online/cleanupimage/restore health to repair the Windows image, ensuring OS integrity and stability. Testing RAM integrity with memtest86. While you upgraded your RAM, faulty memory modules can still cause system freezes. Download and create a bootable memtest86 USB drive, then boot your system from it. Run a comprehensive memory test for several passes. Any errors detected indicate potentially faulty RAM, requiring replacement. Monitoring CPU and GPU temperatures. Overheating components can trigger system instability and protective shutdowns, often appearing as a freeze. Use monitoring software like HW Monitor or MSI Afterburner to keep an eye on your CPU and GPU temperatures. Ensure your cooling solutions are adequate and that dust hasn't accumulated in your case, restricting airflow. Considering a fresh Windows installation. As a last resort, if all other troubleshooting steps fail to resolve the persistent freezing, a clean installation of Windows can eliminate deep-seated software conflicts, corrupted operating system files, or obscure driver issues. This effectively resets your system to a pristine state, often resolving complex stability problems. Don't forget to follow Teknobalta for more in-depth technical guides and solutions.